fibres. The research centre in Britain that breeds grasses and clovers for grazed pasture systems, they are beginning to produce grasses with deeper roots. We realise that we've been breeding crops, including grass, for the above ground production, but we really need to look at what's happening below ground. And so our crop breeders are beginning to think about rooting, root distribution, root depth, and so we're coming at it. Jerry was talking about perennial crops. We're coming at it from the point of view of annual crops having better roots. So two different directions, but the same kind of aim. And if you've got deeper rooting crops with bigger roots, better roots, then there's some option there for sequestering carbon at depth, in other words, below the plough depth. So it might be protected more effectively. Maybe there are options for biocontrol of pests and diseases, inhibition of nitrification, and we're looking at that a little bit, whether some of these crops would exude various chemicals that would restrict some of these processes. So some options there. And we think we've got some data from a 14-year-old miscanthus trial where we've got certain varieties where below the plough layer there's some indication of some carbon sequestration at depth. Small amounts, but it looks to be real, and we've tried to measure that with delta 13C. It's not every variety of miscanthus, but there are some options for these deep-rooting crops sequestering carbon below plough layer. So some optimism there. A few words on biochar. We know what it is. It's not just charcoal, it's material that's pyrolyzed under very carefully controlled conditions to produce a particular product with a degree of porosity and cation exchange capacity, active surfaces. It's very stable, or at least it's claimed to be very stable, but people are beginning to question that. Lots of proposed benefits for soil, increases in soil carbon stabilization, better crop performance, water holding capacity. The problem is that there are huge gaps in